Okay, Bismillahirrahmanirrahim. So this lecture is about recursion, and I've also uploaded a basic tutorial on recursion as well on my YouTube channel. And today, in this discussion, I'll be talking about uh, an example, a very interesting example, and a very old problem of Tower of Hanai, and how to solve that problem using recursion. So let me just explain the problem first. And the problem is that you have got like three pegs here in which you can actually place some disks, and these three pegs are here. So we can call these pegs as, let's say, I'll just name them. I'll say that this is peg A, and this is peg B, and this is peg C. Um, and we have got some number of disks. So uh, let's assume that you have got one disk of one size, and A is the source peg, B we call it the auxiliary peg, and C is the destination peg. So what we want is that we want to shift all the disks. In this particular case, there is only one disk to the destination peg, and they have to be placed in decreasing order of their size. So if the largest disk should come at the bottom, and on top of this, the next largest disk would come. So in this particular case, there is only one disk here, and you can very easily take this disk and straight away like put it in this desk on this peg here. And for that, um, I mean, you can easily transfer it here. So that is like when you have got only one, say, for example, disk. Let's assume that now you have got two disks, right? And these two disks are obviously of different size, and they are in the source peg now. So this is disk number one, and on top of that you have got disk number two, right? Or you can call this one as one and this one as two. And now if you want to move these disks in the same order to peg number C, which is the destination peg. Now what you can do in this particular scenario is that obviously it's not that difficult. You take this disk and place this disk in the auxiliary, or you can call it the supporting peg. And then once this is shifted there, then you take the larger disk and you straight away move it to the destination peg, because when you will remove the top disk, there will only be one disk that would be left in the source peg, which is A, and this will become a problem. So if you remove this, then this becomes a problem. Yeah, okay, so let me just remove this from here, and I'll just place this disk uh, here. And now you can see that this becomes a problem similar to that one disk problem that we discussed earlier. So you can take this disk straight away, put it in the C, and as a result of that you will have the disk here, and this gets removed from here. Now similarly, you have a similar problem that for a single disk uh, is present in let's say the supporting peg. So you take this disk from the supporting peg and put it in your destination peg. Again, it becomes a one disk problem. Okay, so the idea here is that if you have got, let's say, more than one disks, then you can use the supporting peg, which is the auxiliary peg, which is B in this particular case, uh, in order to move the disks from A to C. So if it is a single peg, then it's basically, if in programming terms, if you write a program that moves disk from a single disk from your source peg to your destination peg, then you can actually call it, or to any other peg, you can actually call a function again and again, if this condition is satisfied, which I've just told you. You take a single disk from one peg and put it to another peg, and if it is single disk, you can directly place it in your peg number C. So that means that if I write a program that moves disks from one peg to another peg, I can check on a condition. Okay, if it is a single disk, then I can straight away, and if it is present in the source, let's say peg, or in the auxiliary peg, if it is single, then I can straight away move it to the destination without using the auxiliary or the supporting peg. But if I've got more than one disks, then I have to use the auxiliary peg or the supporting peg in any case. So let's take an example again with three disks here. Okay, so let's say you have got disk number, you have got one disk, then you have got another disk, and then you have got another disk here, right? So these are the three disks that you have got, and the destination is to move these disks in the same order in peg number C. Okay, so what you can do here is that the simple thing that you can do here is that if I can somehow remove these two from the top, then I'll be left with only the largest disk in my peg A. So if I'm left with the largest disk in peg A, which is the source peg, then you remember this becomes a problem similar to the initial problem that I've just told you of a single disk. So then I can take this disk and put it directly in C. But for that, I'll have to remove these two disks. So how will I remove these two disks? I can like remove these two disks in some particular fashion. Say for example, the order would be that I'll take, let's say, C here, the top disk, put it in C first, then the second disk, put it in B, and then okay, so this disk for example goes here, and this disk goes here, and then I can take this disk and put it here. So the order would always remain the same, and the top disks, the two disks, will then end up in peg number C. So I can do that. Okay, so I need not to go into those complexities, but I can write down a program or a function for that. Okay, so what I'll do here is that I'll just take these two disks and I'll say that I've through some process I'll move these disks to this particular peg. So I'll have, let's say, the second disk here, and then uh, the first disk here, and these disks are removed from this peg, and then I'm left with this disk here, and I can straight away take this disk from here and place it here. Okay, so then the largest disk actually comes here, and that means that I've actually removed it from here. Okay, so what would be the next thing? The next thing is that I'm using the supporting peg here. The next thing is that through some mechanism, and that mechanism would be that you shift this to A, the top disk to A, and then you move the remaining, the second disk to C, and then you take, okay, so we'll do it. We'll take this disk, which is the top disk, and place that top disk, let's say in A, move it there, and you see now this problem actually becomes a two peg problem. Okay, so move it here, so I'll actually move it here. Okay, and then this goes away, and I've now left with a single peg problem altogether. So then I'll remove this disk from tower B, which is the auxiliary in this particular scenario. Okay, and I'll just place the disk to the destination here, and then I'll take this and place it here, right? And I can now remove this. Okay, so this is how I'll actually do it. So you can see that if I've got, let's say, so there is one thing that you need to note here, that before you actually do this, for example, um, if I've got, let's say, if I'm removing these two disks here, um, and let's say, okay, let me just move to this scenario. Okay, so now in this particular case, my destination is actually C. I want to put all of these, I want to take both of these, okay, and want to put them in C. So C becomes my destination. But in this particular scenario, I'll be using A. So A in this particular scenario will become my supporting peg. So the definition, or the definition of the supporting peg and the destination peg and the source peg would remain, could change over time. So now my source peg is actually B, my destination is C, and the supporting peg has become A. So using A, I'll be shifting these disks to C. So the idea here is, if I've got one disk, I'll just straight away take it from the supporting, say from the source to the destination without using any supporting peg. If I've got two disks, then I can shift say one to the supporting, right? And then I can shift the remaining one from A to the destination. So if there are two, then this is the sequence. If there is one, then this is the sequence. And if there are three, then obviously I'll from A I'll shift two disks to B. Okay, and this would also have some, say, sub tasks. For example, straight away this can't be done. So what can be done is that I can actually uh, move, let's say, the first one, um say, for example, what I'll actually be doing in case of two disks is that I'll actually have to move it to B, both of them in the same order. So I'll take the first one and put it to C. Okay, and then I'll take the second one and put it to B. Okay, and then I'll move from C to B, right? And then one disk will be left in A, and I'll move one disk from A to C, and then from say, for example, from B, I'll actually be moving to A, right, the disk, and then B will be moved, B disk, what is left in B will be moved to C, and finally the disk in A will be moved to B, to C. Okay, and these are the steps that you will be requiring for three things. So in every case, there are primarily two things that are happening. There are two things that are happening. One is that you take a single disk that is present, if it is the largest disk in there. You take it from your source and put it directly in this onto your destination, or you'll have to use your auxiliary or supporting peg to do that. And same would happen in case of four disks and then n disks. Okay, so we can actually do all of these different things together. So the basic idea is, so let's say if you have got, let's say, n disks, you have got n disks. Let me just draw these n disks. So you have got, like, let's say, one, then you have got another one, then you have got another one, then you have got another one. So if you have got n disks here, and then probably you have got another one. Okay, so if you have got n disks here, so what you can actually solve this problem by taking n minus 1 disks, okay, to the auxiliary, and then the nth disk can directly be moved to the destination, okay, and then from the auxiliary these n minus 1 disks would be moved to C. And this is, in a way, a problem that can be solved through recursion, right? So you can see the repetitions that are happening here. So if I write a function that moves disk from one peg to another peg, I can repeatedly use that by changing the source and the destination and the auxiliary definition, sometimes from A to B to C, in order to move these disks, right? Okay, so this is primarily the concept in this particular scenario in which this problem can actually be solved. Okay, so now we can, for a while, we can move on to the programming bit and see that how the programming part can actually be done. Okay, just bear with me a few seconds. Okay, so here is a programming environment, and let's just try to write down a small program that would help us identify, that would help us in solving this problem. Okay, so let's just write down a function, and I'll call this function as TOH, which is the tower of an eye problem. This function actually takes in n, which is an integer, and that is primarily the number of disks that you are using. Then there is a character. You can write down A for the source peg, and you can write B for the auxiliary peg, and you can write C for the destination peg. And this is how initially the problem can actually be solved, and then we can write down the code. And let's just see that what would be present in this particular uh, program. Okay, so this is how this program will look like. Okay, um, okay, so what is this piece of code doing? So if you have got n is equal to 1, so this becomes a single disk problem, and your source is, let's say, uh, you have some source peg, and you have the auxiliary peg, and you have got the destination peg. So what you can do is that you can move this disk, which is a single disk, and n is equal to 1, from the source directly to the destination. And this is what was done in case of a single disk. Okay, now what happens if you have got n minus 1, uh, n minus 1 disks? That means that if you have got uh, 2 disks, then you will have to use the auxiliary peg. If you have got, let's say, 3, then again you will have to use the supporting peg in this particular scenario. And this is what would happen in this particular case. Okay, so what is this line number 21 doing? Line number 21 is doing this. If you have got n minus 1 disks, that means that if there are more than 1 disks that are present, then your auxiliary becomes your destination. Okay, the last argument, if you remember here, the last argument in the function is the destination. Okay, so now the last argument in this function becomes your auxiliary. So that means that you'll have to move these disks, which n minus disks, you have to move them from your source to the auxiliary peg. Auxiliary becomes your destination, and which peg has to be used? Peg C, which is the destination peg, that has to be used in order to move. So remember, in case of 2, आपने एक डिस्क को उठा के जो था वो एक्सिलरी में रखा, और फिर एक्सिलरी से उठा के आपने या डेस्टिनेशन में रखा, और वहां से आपने फिर उसे एक्सिलरी में दोबारा लेके आए। ठीक है, तो इस तरीके से आइदर यू प्लेस इट डायरेक्टली टू योर डेस्टिनेशन, और यू प्लेस इट थ्रू योर एक्सिलरी ऑन टू योर डेस्टिनेशन। तो इस केस में एक्सिलरी जो है या सपोर्टिंग पैग जो होगा वो आपका पैग नंबर 2 है, विच इज प्राइमरीली योर डेस्टिनेशन पैग, जिसको हम सी कह रहे हैं इस केस में। तो दिस इज ए, दिस इज बी, the source is A, auxiliary is B, and destination is primarily C. तो यहाँ इस लाइन का मतलब ये है कि my source is A, my auxiliary becomes C, and my destination becomes B. Okay, and this is what is happening. And then what you can do is that, okay, what is this function doing? This function is primarily moving the disks from your source to your destination, and your destination, as we know in this particular case, is your auxiliary. So in this case, all the disks will primarily be moved, and -1 disks would primarily be moved from your source to your auxiliary. And then there is another call, the same call to the function, and you can see that this is become a recursive problem, because within this TOH function you have got a TOH function call, and then you have got another TOH function call. And what is this TOH function call is doing? The second one, पहली लाइन नंबर 21 क्या कर रही है? n-1 डिस्क को उठा के सोर्स से एक्सिलरी में डाल रही है सबके सबको, ठीक है। और फिर लाइन नंबर 23 क्या कर रही है? एक्सिलरी से n-1 डिस्क को उठा के डेस्टिनेशन पे डाल रही है, राइट। एंड दैट इज व्हाट वी एक्चुअली डिड। रिमेंबर, तीन डिस्क जब थी तो ऊपर वाली 2 को उठा के हमने एक्सिलरी में डाला था थ्रू वट एवर मैकेनिज्म। उन डिटेल्स में हम नहीं जा रहे, फॉरगेट अबाउट द डिटेल्स कि पहले किसको किस में डाला और फिर कैसे हमने किया। लेकिन 3 डिस्क थी, 2 को उठाया, किसी तरीके से हमने उन 2 को उसी पैटर्न में एक्सिलरी में डाल दिया, और फिर डेस्टिनेशन को उठा के हमने डेस्टिनेशन में सोर्स में से जो लार्जेस्ट थी उसको उठा के डेस्टिनेशन में डाल दिया, और फिर वो जो रिमेनिंग दो जो थी जो एक्सिलरी में थी उन 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 फाइल्स उन डिस्क्स को उठा के आपने डेस्टिनेशन में डाल दिया। तो जो सेकंड स्टेप है एक्सिलरी से उठा के डेस्टिनेशन में डालना, दिस इज बीइंग इम्प्लीमेंटेड इन लाइन नंबर 23। सो लाइन नंबर 23 में माई सोर्स बिकम्स द एक्सिलरी पैक, ठीक है, यूजिंग द सोर्स। तो जो एक्चुअल सोर्स था अब मेरा वो सपोर्टिंग पैक बन जाएगा, ठीक है, और डेस्टिनेशन वही है जिस डेस्टिनेशन से मैं वो कर रहा हूँ, ठीक है। तो इसका मतलब क्या है कि अगर मेरे पास एक डिस्क है तो मैं डायरेक्टली सोर्स से उठा के उसको डेस्टिनेशन में डाल दूंगा। अगर मेरे पास n-1 डिस्क हैं तो पहले मैं सोर्स से उठा के एक्सिलरी में डालूंगा उनको, और फिर एक्सिलरी से उठा के डेस्टिनेशन में डालूंगा। दिस इज व्हाट दिस प्रोग्राम is actually doing. And now let's just write down the main program, and that main program would primarily be using अच्छा, इसमें सी आउट स्टेटमेंट्स डाल लें ताकि सीक्वेंस का हमें पता चल जाए। तो एन हम इंटीजर एक डिफाइन किया है, सी आउट नंबर ऑफ डिस्क हम इसमें एंटर करेंगे, और उसके बाद ये फंक्शन कॉल करेंगे विच इज़ दिस फंक्शन। एंड व्हाट इज़ दिस फंक्शन एक्चुअली डूइंग? इट्स एक्चुअली कॉलिंग एन डिस्क को लेगा, ए बी और सी को उसमें जो है वो करेगा। सी मेरा डेस्टिनेशन है, ए मेरा सोर्स है, और बी मेरा एक्सिलरी है। So let me just run this program and see what happens in this particular case. Okay, so I'll enter the number of disks. Let's say कि मैं number of disks को 3 enter करता हूँ, and then I run this and you can see what has happened in this particular case. Right? So you can see कि ये सारे steps जो है ना, these steps have been followed. And now this code is present in the slides. आप उस कोड को लेके खुद रन करें और देखें कि क्या ये स्टेप्स जो हैं वो ठीक आ रहे हैं या नहीं आ रहे। ओके, सो दैट्स इट, थैंक यू वेरी मच। I think this would be an interesting